Hello students, welcome to another lecture on logic design. We are in the process of studying binary arithmetic, in particular binary multiplication. As you know, there are two methods for multiplying in binary, the paper method and the computer method. In this video, we will learn the computer method for multiplying two numbers. The general concept here is that if you take a number which is of size p bits and multiply it with another number of size p bits, you will get a product that is 2p bits in length. I have written it here for better understanding. If you take p bits and multiply it with another number p bits in length, the product will be equal to 2p bits in length. So if p is equal to 2 bits, taking an example, 1 1 multiplied by 1 1. Use the paper method to solve and get the answer as 1 0 0 1. Notice that the product is 4 bits in length. This method also assumes the use of two registers. What is a register? A register is basically a storage space in computer memory with a certain size capacity. For example, I can have a register named as the accumulator and its size will be of 16 bits. I can use it to store the results of any arithmetic operation, but I can store only 16 bits of information in it. So in this computer method, we make use of two registers, a multiplicand register labeled as M and a multiplier register labeled as MQ. M register is p bits in size and MQ register is 2p bits in size. So it is obvious from here that the MQ register will store the final answer of multiplication. Let us understand this with an example. Multiplying two binary numbers 1100 and 1001. When multiplying two numbers, the first number is always called as the multiplicand and the second number is the multiplier. In the previous slide, I mentioned two registers, the M register which contains the multiplicand and the MQ register which will contain the multiplier. Whenever a computer is supposed to execute something, we have to give it an algorithm or a procedure to follow. So what we need is an algorithm. The first step is as follows. The multiplier is placed in the left p bits of the MQ register and the right p bits are set to 0. Multiplicand is placed in the M register. Now that we have read this step, notice that we have already placed the multiplicand in the M register. Also, in this case, p is equal to 4 bits since the multiplier is made up of 4 bits. So this step tells us to place the multiplier in the left 4 bits of MQ register and the remaining 4 bits will be set to 0. So if MQ register looks like this, we place the multiplier in the left 4 bits of MQ register. And in the right 4 bits of MQ register, we place zeros. Now we are ready for the next step. In the next step, MQ register contents is shifted 1 bit to the left. If 1 is shifted out, M is added to MQ. If 0 is shifted out, 0 is added to MQ. So, shifting the contents of MQ register by 1 bit in the left direction looks like this. Notice that the MSB of MQ register is now shifted outside, and for clarity, I have highlighted that bit in a yellow cube. So since we have shifted 1 bit out, another bit has to enter from the right side. That bit we will put as 0. As per step 2 in the algorithm, 1 is shifted out. So we need to add the contents of M register to MQ. Recall that M register contains the number 1100. After adding, we get the answer as a partial sum which is still contained in the register MQ. We are now ready for the next step in the algorithm. This process is repeated p number of times, where p is the size of the number in MQ register. So we need to repeat this entire process p number of times. Recall that p is equal to 4. Now I know you must be all bugged at this moment, thinking how mundane this algorithm is. But that is the reason why computers were invented, to do mundane tasks which are repetitive in nature. So now we do the entire process all over again. Shift MQ register 1 bit to the left. Replace the bit lost with a 0. Notice that we have shifted a 0 out, highlighted in a yellow cube. So as per step 2 in the algorithm, we need to add 0 to the MQ register. So go ahead, add 0 to MQ. Calculate the sum as. This completes 2 times of the same process. Do not roll your eyes, but carry on for another 2 times. Again, we shift MQ left 1 bit. Replace the bit lost with a 0. Notice that we have shifted a 0 out. So as per step 2, we need to add 0 to MQ register. So go ahead and add 0 to MQ. Calculate the sum as. This completes 3 times of the same process. Be brave, this is the last time we do this process. Shifting MQ register 1 bit to the left. Replace the bit lost with a 0. Notice that you have shifted a 1 out, highlighted in a yellow cube. So as per step 2, we need to add M to MQ register. Recall that M contains the value 1100. So go ahead and add M to MQ. Calculate the sum as. This completes the algorithm. The final product is in MQ register. You can verify this answer by multiplying these two numbers using paper method. That's all for now. Try your hand in multiplying the following 2 binary numbers. Connect to the classroom for further videos and learning material.